This paper is an update on the asphalt rubber pavement preservation strategies in California. My co-authors are Anne Stonix and Gary Hicks from MacTech. The presentation outline asphalt rubber modified binders, our Caltrans experience with asphalt rubber strategies for pavement preservation. I will talk about the performance and a case history and give you some conclusions. Basically, there are three types of asphalt rubber binders. One is the wet process, which is basically the process that's been used commonly in California. And also, under the wet process, type 1 and type 2. California experimented with both type 1 and type 2. Now California is mainly using type 2 asphalt rubber binder, which uses extended oil. The state of Arizona is still using type 1, and they have experienced successful performance. However, based on our field performance in California, we decided we were going to use type 2, and we've done that for asphalt rubber hot mix and also for seal coats, chip seals. And this experience basically is based on the performance of the projects. And we are also looking into this type 1, type 2 at this moment for seal coats based on the recent performance of asphalt rubber chip seals in some of the warm districts. Then we have, we're experimenting with thermal blends, 15% chrome rubber. And also we've experimented with the dry process. Our history goes back many years, since the early 70s with chip seals. And then we've developed the experience and with the density graded, open graded hot mixes, where we use rubberized asphalt concrete open graded and rubberized asphalt concrete open graded with high binder. And the difference between the open graded without the high binder is that the binder content in the regular open graded asphalt rubber open graded is about 20% more than the conventional open graded, whereas with the high binder it's more about 65% more than the conventional open graded with just conventional asphalt. So the high binder is very has heavy coating of asphalt rubber, and we consider that a very good strategy because it provides a durable and long-lasting surface. Although we reduce some of the anti-splash benefits, we gain the durability aspects of it. And recently we have experimented with bonded wearing course. We have developed specifications. I've done several projects using bonded wearing course for open graded. And also we are planning on having a bonded wearing course gap graded asphalt rubber. So that's another strategy that we've added to our toolbox in pavement preservation. And we have developed several guides that will help us achieve successful performance based on our experience. Basically, the application history of asphalt rubber in California since the 60s or let's say late 70s or mid 70s until 2006, this is a gradual increase of the various types of strategies from asphalt rubber chip seal into using interlayers, SAMIs, stress-absorbing membrane interlayers, in addition to the open-graded mixes, density-graded mixes, and gap-graded mixes. These are the strategies that we have utilized for pavement preservation. Why do we use asphalt rubber in pavement preservation? because it has proven to us to be a cost-effective approach toward extending our pavement life. We are interested in determining the extended life benefits of pavements due to pavement preservation. We have a very strong pavement preservation program in California, and California is one of the leading states in pavement preservation. And asphalt rubber plays a major part in our pavement preservation program. We consider the asphalt rubber strategies as the premium strategies when looking at the various types of treatments. Asphalt rubber resists reflective cracking, and it has been proven over and over again with many of the different types of tests and field performance that the reflective cracking ability for asphalt rubber chip seals in particular and the other strategies is tremendous. We have looked at many projects where the cracks don't reflect for many, many years. For the open-graded rack or rubberized asphalt concrete open-graded, it's also very resistant to reflective cracking. This is a very good material as a surface. In fact, it has provided us with confidence in using rubber statewide and pushing this strategy to be utilized more and more. It improves surface friction. It has the noise reduction ability. We have in California the Quiet Pavement Program, where we have been using asphalt rubber open-graded and evaluating different other strategies and comparing them with each other to see how can we reduce the noise with surface treatments. So pavement preservation basically is one of the aspects or the benefits is noise reduction. And we have the sound wall program, which is federally mandated for high noise levels when we design noise for 20 years projection, where we build sound walls, and that blocks the scenery for houses and residential areas. And our objective basically is to have a surface that can reduce the noise and do away with the sound walls. And when we compared that with PCC pavements, we have gained about 7 decibels in reduction using open-graded. 7 decibels means we don't need to use a sound wall in some instances. So we have developed a proposal and sent it to Federal Highway Administration so that we can utilize this strategy and be able to use it in lieu of sound walls. The reason we have noise reduction with open-graded, that's a good question and has been studied by, or let's say looked into deeply. Open-graded, the fact that you have an open gradation, you have the noise dissipation, that the noise goes into the voids and gets dissipated. The fact that you have asphalt rubber, it gives you the durability of that treatment to last much longer than when we had conventional mixes. So an open-graded with asphalt rubber is a premium strategy to use when we are looking at noise reduction. Of course, in addition to the other benefits of helping with against oxidation of the surface and with the anti-splash and reducing hydroplaning. Open-graded hot mix has been used on the freeways here. This is one of the experiments or the pilot projects that we've done with the pilot program, where we put this in one of our districts on I-80, that's the freeway that goes from San Francisco to Reno, and has been performing well. And of course, Arizona has been using a strategy like this for several years. Open-grade hot mix, the high binder, which I mentioned, it has 65% higher binder content than the conventional open-graded. It's much more durable and much more resistant to reflective cracking. The gap-graded rubberized asphalt concrete, gap-graded, is also very good resistant to reflective cracking. This has been used in our rehabilitation program as well as in pavement preservation. Typically, the pavement preservation thickness is about 30 millimeters, 25 or 30 millimeters. They are very thin surfaces. So the rack or the rubberized asphalt concrete gap graded is an excellent in fatigue and reflective cracking behavior. We've done many tests using the bending beam test, using reflective cracking tests, in addition to the HVS, heavy vehicle simulator, all indicate the excellent behavior of asphalt rubber gap graded. The binder content is pretty heavy, about 7 to 9%. And we have utilized this in reduced thickness. We have reduced thickness design based on its performance. So it has the fact that the fatigue laboratory tests and reflective cracking tests have shown that it's more than 10 times better than conventional density graded asphalt concrete, has helped us develop the design guides in reducing the thickness by about 50%. And recently, as I mentioned, we have specifications for bonded wearing course, open graded and gap graded. This type of strategy uses a heavy emulsion membrane on the surface, and you add to it a very thin layer, about 3/4 of an inch of a surfacing. And we have built several projects with this strategy here. In addition, we have developed technical guides, the 1992 Reduced Thickness Design Guide and the recent updated 2006 guide, which there will be a presentation, I think, tomorrow in the applications sessions. Plus, we have the Maintenance Technical Advisory Guide, which has also, all of these strategies are on the Caltrans website. That can be used also to help anybody who wants to implement an asphalt rubber program. We have a lot of technical guidance. We have a lot of experience to be able to help you and support those people who need some help. Many of the tests over the years, since 1992, when we developed the reduced thickness design, we've done validation tests using the accelerated pavement testing program and using shear testing and fatigue testing and in-service pavements. We've looked at the rutting, fatigue behavior, reflective cracking, and moisture sensitivity. I mean, we've done an extensive research program to evaluate these materials. And we have confirmed the reduced thickness design concepts through field tests and through the heavy vehicle simulator. We've done surveys statewide. We have many projects in every district under different climatic zones. And one of the benefits of the reflective cracking benefits of asphalt rubber is amazing. Even when the cracks show up, they don't open up the way the cracks open up with conventional asphalt concrete. They always stay tight, and that's the nice. So you get a smooth pavement that continues to be smooth even when you have cracks. This is one of the performance reviews that was done by a group of Caltrans industry. It's a major team that was looking to various projects statewide, and basically the evaluation showed the good performance of asphalt rubber strategies. We've had field reviews in 1998, and recently we've had a review of asphalt rubber chip seals. And there will be a presentation on that review on Friday by Larry Ruin from Caltrans. And we are basically enhancing our specifications based on the recent review, because not all of the projects we have that were completely successful, and so the projects that we've had some failures, we've learned from them, and we have enhanced our specifications to ensure successful projects. This is another evaluation that was done in 1999, which also confirmed the good performance. We have here, we built in 1993 or test sections in 92 near Esparto, California. And those test sections utilize various types of strategies: open graded, gap graded, chip seals. We use SAMIs. Some sections were with SAMIs, stress absorbing membrane interlayer, and some without, and with different thicknesses. And all of these strategies were very thin. They were like 25 or 19 millimeters even. So the 1993 compared to the 2001, you see the difference here for ½ inch maximum size for an asphalt rubber chip seal. The performance was excellent. Here also another project, that's the gap graded, okay, 25 millimeters, good performance. And this is the gap graded with a SAMI. That also shows a better performance than with the one without SAMIs. And then we have the open graded 25 millimeters, which showed excellent performance. Also 19 millimeter thick open graded also. And also open graded with a SAMI, 19 millimeters. And we had also 13 millimeter thick. Also, we went even thinner, 13 millimeter. Another one with SAMI and without SAMI. Basically, the sections that had SAMI had less cracking. So the SAMI with the pavement preservation strategy is an excellent strategy, utilizing an interlayer below that thin layer. And that performed excellent. And the other finding, of course, was the thicker the better. So if we use 30 millimeters, it's much better than using 19 millimeters. So thickness is very important for reflective cracking. Also using SAMIs is very important. So in conclusion, basically that pavement preservation strategies that utilize rubber are very successful and superior to strategies that do not use rubber. Has been confirmed with many tests, laboratory tests, and accelerated pavement tests. Thank you.
Questions, please.
Well, let me start off with a qualifier. I do like rubberized AC, but I just have a couple of questions because noise is becoming a very big issue down in San Diego County. And the talk is putting, a rubberized friction course over concrete. And you made a statement about a 7 dB reduction in noise. And so my question to you is, what kind of condition was that concrete that was compared to the rubberized AC? And were there other options that could have made the concrete quieter itself? Again, I don't know if in all cases that we want to put rubberized AC over concrete, so I would like to see you talk a little bit about that. Thank you.
I like your comment because I struggled with it myself. Because I would like to preserve concrete pavements as concrete. Concrete has been very successful strategies, has given us good performance over the years. That's a good point. Do we want to utilize this strategy everywhere? Arizona does, I think. But I believe there are places where we can use open-graded, where it is very sensitive that we need to utilize it for basically providing the aesthetic, instead of putting a sound wall, where you can create a problem and close the scenery. Open-graded, can last over 10 years and more, okay? So that's a benefit. Yes, you need to come in and do something else later on, where in concrete, maybe you don't need to do that, okay? So this is one of the things that we have to weigh and think about. But for example, we use longitudinal tining. Arizona use horizontal tining. So that also makes a difference in noise. But yes, we have done the testing and we have shown that even with our tining, the reduction in noise, there is a big benefit in that. Okay.
I've got a question that goes along with the noise mitigation thing. You indicated that you were proposing to FHWA to use open-graded friction courses and so on to mitigate noise. Is that a pilot project like Arizona's, or is that going to be a blanket kind of policy for FHWA?
Well, we are looking into this program, which includes a lot of evaluation, okay? Arizona has also been pioneering in the noise area, okay? This noise program is not just talking about the open-graded, of course. It's going to be evaluating various types of treatments, okay? And seeing if we can use those to be able to use them where we can use sound walls, possibly in certain areas. But it's not just toward open-graded, but in our experience, open-graded is the material that shows the most benefit in noise reduction.
When you've done your sound wall studies, have you taken measurements outside of the farther past rather than right where you're putting up the sound walls? Because isn't it true that the waves are reflected and then you're just pushing them out farther, so you're affecting a different set of constituents rather than right by the edge of the pavement?
Yeah. When we did our noise studies, we have done measurements. Of course, one is about 50 meters away from the trucks. Also, we have taken measurements right by where the wheel interacts with the pavement, okay? And we had the monitoring devices to take the measurements there, where you can basically measure the effect of the tire surface noise rather than the engines. Regarding reflecting from sound walls, that could be a problem too. Sound walls cannot be very high, of course. People at second floor buildings there's no benefit for them either.
There has been cases and studies that show that some of that sound is reflected up to a half-mile away and just bounces down to a different set of people away, that they've noticed a big change on stuff like that. So one of the things which you do, if you can reduce it at the tire noise, then you're not having that go out.
See, that's the idea, is to reduce the noise at the tire pavement interface area.
It's alleged that the frequency of the noise changes and that a rumble factor can be a problem when the road noise is reduced. Can you comment on that?
Can you repeat the question, please, again?
It's basically the rumble factor in terms of there is a reduction in frequency producing lower level noises which have a very much different psychological effect than normal frequency, so that by the 7 decibel noise reduction, you may well be reducing the noise level, but you may be changing the frequency to a lower frequency that can also have an increasing impact. Do you have any information on that?
That's a good comment. I think yeah.
Good.
Actually, it goes the other way around. The concrete pavements happen to have noise level exactly at the frequency range between 1,000 and 2,000 hertz that our little sensors here don't like. So when you put an asphalt rubber, not only you have less decibels, you have less energy at that frequency between 1,000 and 2,000 hertz, which is particular, we don't like it. At that level, it comes down. At that frequency range, it comes down.
You showed a slide for some I-80 repairs where I assume it was an asphalt rubber overlay over the existing Portland cement concrete roadway.
Yes.
On other interstates, I-80 and the other interstates in the state, if the decision is made for pavement rehabilitation is to overlay the existing PCC, is the final course, is it Caltrans policy that the final course will be asphalt rubber?
No, there is no policy about that. We still use our own. These are pilot projects that we are using in the state, so we don't have a policy that it has to be asphalt rubber.
If a local agency requests, because of residential areas adjacent to the freeway, if they request that it be asphalt rubber, is that taken into consideration?
Well, there's a partnership between Caltrans and local agencies on projects that basically a lot of negotiations goes on. And one of the strategies can be asphalt rubber. I mean, we look into various strategies.
The test strips you did in '93, which type of binder was used? Was it the Arizona binder or the California binder with the extender oil?
I believe it was type 2 binder.
Do you notice any difference between the two? We've been with type 2 for a while.
Yeah, we've actually, based on some of the reviews we've done in the past, there was a report a while ago that showed that there were projects that were performing much better, those hot mixes with type 2. And so we pretty much switched to type 2.